Assalamualaikum warahmatullahi wabarakatuh. My name is NABIHAH binti ABDUL MA20010. We will be presenting about Bernoulli'S theory. We are from section 2 and group 2. For our objective is to demonstrate how Bernoulli's principle applies to incompressible liquids. We also want to understand the idea of a liquid's energy conservation and to determine the velocity of fluid, static head and total head. For our introduction, Bernoulli's principle is a fundamental relationship between flow rate, driving pressure, density and other forces driving fluid flow in fluid mechanics. According to Bernoulli's principle, if a fluid is moving horizontally at specific speed, the pressure around it will be decreasing, hence reducing the fluid speed. Bernoulli's equation can be derived by using the concept of energy conservation, where static head plus dynamic head plus elevation equals to constant. In this experiment, static head and total head measured from point A to point I with 5 flow rates taken. The flow rate is measured through a volumetric bench.
Assalamualaikum warahmatullahi wabarakatuh. My name is ADLINA NADHIRAH binti HISHAM, MA20041. Today I will talk about the theory in literature. So Bernoulli's principle of fluid dynamics asserts that an increase in a fluid speed happens concurrently with a drop in pressure or a decrease in the fluid potential energy. The venturi tube is a practical use of Bernoulli's principle. The venturi tube has an air entrance that narrows to a throat and an output segment that widens toward the back. The outlet's diameter is the same as the inlet, and the mass of air entering the tube must be equal to the quantity of air exiting the tube. The speed must rise at the constriction to allow the same volume of air to travel in the same period of time as in the rest of the tube. When the air speed increases, the pressure falls, and the airflow slows as the pressure rises beyond the constriction. If the behavior of the fluid flow near the foil is understood, Bernoulli's principle may be used to determine the lift forces of an airfoil. For example, if air flowing past the top surface of an aircraft wing moves faster than the air passing past the bottom surface, Bernoulli's principle suggests that pressure on the wing surfaces will be lower above than below. The pressure differential produces an upward lifting force, and the lift forces may be estimated using Bernoulli's equation whenever the speed distribution past the top and bottom surface of a wing is known. So now to differentiate between cases in which Bernoulli's principle provides an appropriate explanation for ordinary events involving flowing air, let us first review what Bernoulli's principle informs us. So, fluid traveling along streamline in a horizontal tube with variable cross-sectional area, and the flow must be consistent, non-viscous, and incompressible. To maintain flow continuity, the fluid in figure above must accelerate as it flows from left to right because the same volume of fluid must move through a smaller cross-sectional area per unit. A net force to the right must exist, and this force is given by a static pressure differential in the fluid. That is, the pressure to the left of A must be greater than the pressure to the right of it. As a result, as the pressure decreases along a streamline, the flow speed increases. So Bernoulli's principle is constant with internal interaction in a fluid since no energy is supplied to or withdrawn from it by an exterior impact. The total of kinetic energy and potential energy is constant. Any reduction in static pressure must be accompanied by an increase in kinetic energy and vice versa. So Bernoulli's principle is also an expression of the law of energy conservation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ARIF BAKRI and trade number MA20028. So I will explain about the methodology. Introduction. This chapter will outline the equipment required for this experiment and explain their methods. Apparatus on this experiment, which is hydraulic bench and Bernoulli's principle demonstrator. So the experiment procedure. Okay, first the pump cork was fully opened, and then the ball cork was closed. After that, the rotameter valve was adjusted slowly to identify the maximum value of the water flow in the tube, and make sure that all the water flow in the tube, and check when the air is completely expelled before reading was taken. Okay, next, the first reading was recorded. Then the volumetric tank was closed, and the time was recorded when the water fills in the volumetric tank 0 until 5 liters. For the next step reading, the rotameter valve were adjusted and recorded by using the same step size on every reading. And last is step 5 until 7 were repeated until the final reading. That's all from me. Thank you.
Okay, my name is AHMAD bin ZAIDI. My number is MA20072. Okay, my part is tell about result, discussion, analysis. Okay, so first of all, we can see the result, which is first we get from the experiment, which is the flow rate. We take 3 result, and there is H1, H2, H3, H4, and H5 and H6, and we snap the area, which is there is A, B, C, and D, F, same area. Okay, after that we are calculate the VMIS, which is every 1 hash we calculate the VMIS, which is the formula. VMIS is Q per E. Okay, so we get the all VMIS for 6 point. Okay, and then after we calculate the VMIS, we do a graph in Excel, which is first one hash static vs position graph. Okay, the second one VMIS vs position. Okay, the result of graph a little bit change, because it's look like quite overall like same. Okay, and then I want to tell about discussion, which is firstly is difference between VMIS and VCAL. Okay, VCAL is consideration of gravitational force and the head difference of fluid from Bernoulli'S principle. Okay, so the fluid system is open and affected atmospheric pressure and gravitational energy law. So the equation which is VCAL is comparison from kinetic and potential energy. Okay, so and then for VMIS, equation for an ideal closed and stable fluid system. This is considered velocity vector and fluid volume. Okay, the second conclusion from static and dynamic. Okay, so what is dynamic? Dynamic is major pressure inside fluid due to kinetic move. Okay, second is what is static head is measure the two pressure, which is atmospheric and fluid affected gravitational. Okay, to have a correct measure, there must be dynamic and static head calculate together, which is called stagnation head or total head. Okay, so number 3 is conclusion static and dynamic opposed to total head. Okay, we can conclude that increase in the speed of fluid will affect static pressure, and kinetic can be decreased. Okay, this is proof that Bernoulli principle is true. So kinetic energy is increasing, there will be a decrease in intentional energy and potential energy. Okay, thank you.